Welcome to Tungal College online classes. Hello students, how are you all? Today I am going to start another important topic from chemical bonding by the name is resonance. The resonance is defined as the existence of two or more Lewis structures for a given molecule is called as a resonance. Now let us understand what is exact meaning of resonance by taking some examples. First I am taking an example of ozone molecule. Example O3 molecule. Ozone. First we have tried the structure of ozone molecule. So I am writing the structure. First oxygen, this is the second oxygen, this is third oxygen. So between these two oxygens there is a double bond, here is one single bond. Then we have to satisfy the octet configuration for each ozone. This bond, only one bond is, this means 2 electrons, remaining we have to write here is 6 electrons, 3 lone pairs. 1, 2, 3 lone pairs are the 6 lone pair electrons. 1, 2, 3 bonds is the 3 bonds, each bond is made up of 2 electrons. Then total number of electrons around this oxygen is 6. Then we have to write 1 lone pair or 2 lone pair electrons. One lone pair or 2 lone pair electrons. Here I am writing 1, 2, 3, 4. 2 lone pairs I wrote are 4 lone pair electrons. 2 plus 2, 4, 5, 6, 7, 8. This is the structure of ozone molecule. I am labeling this structure as number 1, first structure. Right? All oxygens are same. So to differentiate oxygens, I am labeling oxygens as this is the first oxygen, this is the second oxygen, and this is a third oxygen. First oxygen, second oxygen, this is a third oxygen in a structure 1. Now if you look at this molecule, this structure, what the thing understand is there is a double bond between first oxygen and second oxygen. Between the first oxygen and second oxygen there is a double bond. If you look at the first oxygen, third oxygen, there is a single bond, only one bond is present, here is a double bond is present. Now what I am doing is, I am without changing the position of atoms, I did not change the position of these oxygens. I did not change any position of oxygen, but I am changing only these electrons. These electrons are moving to here. So the double bond between the first oxygen and second oxygen moving to the first oxygen and third oxygen. As a result, I will get one more structure. What is the structure is? Initially there is a single bond. Here is a one single bond. This bond I am shifting here, as a result here is a one bond will come, and the remaining electrons we have to satisfy octet configuration. So this is another structure we got. This structure I am labeling as 2, structure 1, and this is structure 2. If you look at this structure, again we have to label, this is the position of atoms remains same. This is the first oxygen, this is the second oxygen, this is third oxygen. Now look at the position. So first oxygen as usual, second, third oxygen so as usual will be there. But what is the difference you identified from first structures to second structure? Is there any difference you identified from first structures to second structure? Yes, we identified one difference. What is that? The double bond is between the first oxygen and second oxygen here, but here double bond is between first oxygen and third oxygen. This bond is moved to here. This is we got second structure. By taking this we can define a resonance. Only one molecule I took. This molecule has we wrote 2 or more structures. In this case we wrote 2 structures. The existence of 2 or more, some cases you will get more structures, here you got 2 structures. The existence of 2 or more structures, Lewis structures for a given molecule is called as a resonance. Now this structure is converting into this structure. If this bond is moved to here, the double bond between the first oxygen and third oxygen, if moved to the first oxygen and second oxygen, you will get this structure. If this bond is moved to here, you will get this structure. So these 2 structures are interconvertible from one another. Now these 2 structures we have to call as resonance structures. These structures are called as resonance structures. The resonance structures are also called as canonical structures. The resonance structures are also called as a canonical structure. Structure 1 or structure 2 are called as resonance structures. These are also called as a canonical structure. Now one more important point is one structure is converting into another structure. While converting, there is one more structure is formed. The structure is called as a resonance hybrid. So what is the resonance hybrid? This position of atoms I am keeping as is one oxygen. This is the second oxygen and this is the third oxygen. The position of atoms I am placing as usual. Clear? Position of atoms remains same. Now this bond is moving to here, this double bond is moving to here. Bond only moving, then these single bonds remains the same. The moving bond, what is the moving bond? Moving from between 1 and 2 to 1 3 and 1 3 to 1 2. I am writing as dotted line like this. This is the bond moving from between these oxygen atoms. This is structure. That means this structure directly won't converting into this structure. This structure first converting into this structure and it will be to this one. And this structure will be converted into this one and later into this one. So one structure is interconverted in the section through a structure we are calling as a resonance hybrid. Resonance hybrid. This structure is called as a resonance hybrid. The resonance hybrid always has a less energy when compared to the any resonance structures or canonical structures. This is a resonance. What is the points we understand from here? So what is the point number 1? Definition. The definition of resonance is the existence of a 2 or more Lewis structures for a given molecule is called as a resonance. Important point number 2. Resonance structures have a similar position of atoms. Position of atoms is similar and different arrangement of electrons. Very important point. Position of atoms 1 2 3 same, 1 2 3 same. Position of atoms or nuclei is same, but arrangement of electrons only different. Here is pi bond with double bond between the 1 and second carbon. Here is double bond between the first oxygen and second oxygen. Here is double bond between the first oxygen and third oxygen. Only double position arrangement of electrons is different. Another important point, these structures have similar bonding and non-bonding electrons. Here is bonding electrons how many? 1 2 3. 3 bonds is there here. How many is there? 1 2 3. Bonding electrons is same. Then non-bonding electrons, how many lone pairs? 1 2 3 4 5 6 lone pair of electrons is there. Look at here, 1 2 3 4 5 6. So non-bonding electrons, nothing but lone pair also is similar. Now what is the things we have observed? The same things we have to write. Point number 1, definition. Definition according the existence, the phenomenon of the existence of two or more Lewis structures. 2 or more Lewis structures for a given molecule. For a given molecule is called resonance. Is called resonance. This is the definition of resonance. Next point, another point, next point. The resonance structures have the resonance structures. The resonance structures have or has what they has? They have similar position of atoms. Position of atoms is similar. Has a similar position of atoms or nuclei and different arrangement. The different arrangement of what? Electrons. The different arrangement of electrons. This is the second important point regarding the resonance. And another thing is the resonance structures have resonance structures, the resonance structures have similar what they are, bonding and non-bonding pair electrons. Similar bonding pairs and non-bonding pairs, non-bonding pair electrons. They have similar bonding pair and non-bonding pair electrons. This is point number 3. And another important point is now the energy we have to compare. Energy of resonance hybrid is less than the energy of any resonance structure. Energy of resonance hybrid, the energy of resonance hybrid is less than energy of resonance structures. Resonance structures. Now there is a difference is there. So resonance hybrid energy is less and when compared to the resonance structures, the difference between the energy, the difference of energy between the resonance hybrid and resonance structures is called as a resonance energy or resonance stabilization energy. The energy difference between resonance structure and that we have take most stable resonance structure and resonance energy, resonance hybrid. The resonance hybrid is called resonance stabilization energy or simply resonance energy. Resonance stabilization energy or simply we are calling as resonance energy. Resonance energy. And another important point is greater the number of resonance structures, greater is the stability. More the number of resonance structures we write, more is the stability of a molecule. The last point is greater the number of resonance structures, greater the stability of molecule. So greater the resonance energy, so greater the number of resonance structures, so greater the stability of molecule. So this is a resonance. And simply resonance is defined as the existence of 2 or more Lewis structures for a given molecule is called as a resonance structures. One main difference you have to identify. What is the main point is they have similar position of atoms, but the difference is they are arranged in electrons. So similar position of atoms is there, arrangement of electrons is different. This is a resonance. Now let us take one more example for the understanding of resonance. I am taking a CO3 minus 2 ion. CO3 minus 2 ion. First we have to write the Lewis structures for CO3 minus 2 ion. Then carbon is least electronegative, placed at the center, and this carbon is bonded to 3 oxygens like this. Clear? And we have to satisfy the octet configuration to the each atom in this molecule. Now I am taking, here is a double bond, and to this oxygen how many electrons is there? 2 plus 2, each bond is 2 electrons, so total number of electrons is 4, and here is requirement is how many? 4. Then I am taking 2 lone pairs. This oxygen valence is, octet configuration is satisfied. Now coming to this oxygen, 2 electrons is there, then 2, 3, 4, 5, 6, 2 2, 3, 4, 5, 6, 7, 8. For this case, octet configuration is satisfied. Coming to this oxygen, 2 electrons, this bond has 2 electrons, then remaining we have to write 6 electrons. So we have to take 3 lone pairs. So 1, 2, 3, 4, 5, 6, this bond is 2 electrons, 8. Even you can take this carbon also has octet configuration is satisfied. So 1, 2, 3, 4 bonds is there, 4 2s are 8 electrons. For this oxygen carbon also octet configuration is satisfied. Now there are 2 negative charges is there in the molecule ion. So one negative charge on this oxygen and another negative charge on this oxygen. This is a structure of CO3 minus 2 ion Lewis structure. I am labeling this structure as a 1. I am labeling this structure as 1. Next, these are the 3 different oxygens. To differentiate oxygens, explanation, they are differentiating by giving numbering. So this oxygen is labeled as 1. This oxygen I am labeling as 2. This oxygen I am labeling as 3. First oxygen, second oxygen, this is the third oxygen. This is a structure number 1 for CO3 minus 2 ion. Clear? Then what I am doing is one more important point here is the double bond between the first oxygen and carbon. Double bond is between the first oxygen and carbon. This double bond I am shifting to here, moving to the carbon and second oxygen. As a result, I will get one more structure. Then what is the structure we can expect from here is carbon. As usual, position of atoms are not changing. Resonance in the sense we should not change the position of atoms. Position of atoms remains same. Only electrons we have to change from one atom to the another atom. That means between the 2 atoms, so we have to change the position of electrons, but we should not change the position of atoms. Only electrons we have to change. Now carbon position remains same. This oxygen position also remains same. This oxygen, second oxygen position also remains same. And even third oxygen position also remains same. Position of atoms remains same. Again we have to satisfy these valences. Single bond, here is single bond. Then this bond is moving to here. Double bond between the first carbon and first oxygen. Now moving this double bond to the carbon and second oxygen. As a result, here I will get double bond. Here I will get double bond, here remains a single bond. The remaining electrons we have to take as usual. So here is a 1, 2. According to octet rule, we have to write a Lewis structure. 1, 2, 2 bonds. In the sense 4 electrons, 4 plus 4, 8 electrons. This is configuration satisfied. For this case, 2 electrons is that this bond is 2 electrons, then we have to write 6 electrons. So these are the 6 electrons, 3 lone pairs. So for this case, octet configuration satisfied. For this case, 1, 2, 3, 4, 5, 6. It is also octet configuration satisfied. Here is the negative charge, here is the negative charge. This is the second structure. Clear? This is second structure. This is the first structure and this is a second structure. Now, what is the difference you notice is and one more we have to label it. This is the first oxygen, this is the second oxygen, this is a third oxygen. Then what is the difference you identified between these two structures? Main the difference identified is there is a double bond between the carbon and first oxygen. In this structure, there is a double bond between the second oxygen and there is a double bond between the second oxygen and carbon. Clear? This is I got second structure. Now what I am doing is this bond I am moving to here. This bond is moving to here. Then I will get one more structure. Then what is the structure we can expect by moving up this bond? Carbon as usual. This position of atoms remains same. This position of atom remains same. This position of atom also remains the same. Position of atoms remains same. Now again we have to satisfy octet configuration for each atom. And what is the thing is this bond is moved on. Again I am labeling this is first oxygen, this is second oxygen, this is third oxygen. Then this bond is moving to here. Then we'll get a double bond between the third oxygen and carbon. We'll get a double bond between third oxygen and carbon. Then we have to satisfy the octet configuration to this oxygen. Now this is here is will get a negative charge. Here is we have to get negative because we took the CO3 minus 2 ion. This negative charge belongs to all the molecule. I already said in previous classes. Now this is a structure 3. Now the question is arises, What is the common difference we identified between the structure 1, 2, 3? The difference we identified is arrangement of electrons is different. But what is the same thing we identify? What is the same thing in this case? Position of atoms are same in all the cases. Position of atoms are same, but the arrangement of electrons only the difference. These three structures, what we have to call first structure, second structure, third structure. These three structures we have to call as I already previously said this structure, and this. These structures are called as resonance structures. Resonance structures. These three structures are called as resonance structures. These are also called as canonical structures. They are also called as canonical structures. Now, we have to draw the resonance hybrid for this molecule. This structure directly won't converting into this structure. This structure directly won't converting into this structure. So the interconversion not possible directly. So one structure is converting into another structure, and this structure converting to this one converting into this one, and the second converting into third structure converting into second structure. Directly not possible. They convert through another structure is called as resonance hybrid. Now let us write the resonance hybrid for this molecule. This ion. So carbon again remains at the center position, and this is the first oxygen, and this is the second oxygen, and this is the third oxygen. Clear? So the first oxygen, second oxygen, and this is a third oxygen, 3 oxygens. So next point is here is the bond bit moving from first oxygen to the second oxygen. So this bond keeping in the form of a dotted line like this. So this is the bond between double bond moving from first oxygen to second oxygen. For this structure, the double bond is moving from second oxygen to the third oxygen. Then we have to write like this. So this meaning is the double bond moving from second oxygen to the third oxygen. Clear? Then this structure is converting into this structure, and we can write one more structure also. How do you write one more structure? Is this structure will be, this one is moved here. If this one is moved here, you will get again this structure. This one is directly converting into this one more structure. So from second oxygen to third oxygen to, the bond is moving from first oxygen. So like this. So what I mean is, if you move this bond from third oxygen to the first oxygen, what is the cycle get? Third to first, this bond came here. Here you will get a double bond. That means between these two oxygens, there is a movement of electrons, double bond. So this is this structure is called as a resonance hybrid. This structure is called as a resonance hybrid. Through resonance hybrid, one structure is interconverting into another structure. So this is a resonance structure for CO3 minus 2 ion. So one more important point is the resonance structures have more energy, and when compared to the resonance hybrid has less energy. So the difference between the resonance energy difference between the resonance structures and the resonance hybrid is called as a resonance energy. Greater the resonance energy, greater is the stability. One more important point is greater the resonance energy. I gave a definition for the resonance. Resonance is the difference between the energy of resonance structures and one structure you can take, more stable structure you can take, the difference between the energy of resonance structure and resonance hybrid. This energy is called as a resonance energy. Greater the resonance energy, greater is the stability of molecule. And one more, greater the number of resonance structures also, greater is the stability. You can take more the number of resonance structures, more is the stability, or you can take greater the number of resonance structures, greater is the stability of that molecule. So this is a resonance of CO3 minus 2, resonance structures of CO3 minus 2 ion. Now I am taking another textbook example for resonance. The molecule is carbon dioxide, CO2. First we have tried the Lewis structure for this CO2. So carbon at the center, and this is bonded to 2 oxygens with a double bond. Then we have to satisfy the octet configuration for each atom. So carbon already satisfied 1, 2, 3, 4, 4 2s are 8 electrons satisfied. This oxygen has 1, 2, 4 bond, 2 bonds, 4 electrons, remaining 4 electrons, 2 lone pairs we have to write. So this oxygen 1 to 4 bonds is there, 4 electrons is there, we have to satisfy remaining 4 electrons by lone pairs. So it has 8 and all the atoms are 8 electrons. This structure I am labeling as number 1. This is the first structure. Now what the thing I am doing is the bond, for understanding purpose, this oxygen I am labeling as 1, this oxygen is labeling as 2. The double bond between the carbon and first oxygen is moving to the between the carbon and second oxygen. This bond is moved to here. As a result, I will get one more structure. What is the structure is carbon. We will get a triple bond like this, and here I am going to get a single bond. Clear? This bond is moved to here. So he will become a double bond already is there. One more bond we have to add a triple bond. Here is a single bond. Again we have to write the Lewis structure octet configuration for each atom. So here is already 6 is there, 7, 8 it's satisfied. It is already 8 satisfied. For this case 1, 2, 3, 4, 5, 6, 7, 8. For this case also the valence is satisfied. Now what is the point is we have to find out the charges. How to find what is the charge in this oxygen, what is the charge on carbon, what is the charge on oxygen. So we have to find out the formal charge. What is the charge on this oxygen? So simply we have to take as a formal charge concept. So what is the formal charge? Formal charge Fc is equal to formal charge is equal to number of valence electrons in the free atom minus number of electrons in the free atom minus number of lone pair of electrons Lp minus half into number of bond pairs. These are the non-bonding electrons, these are the bonding electrons. Now we can take number of electrons in the free atom. So oxygen atomic number is 8, its number of electrons is 1s2, 2s2, 2p4. So what I'm meaning is oxygen 1s2, 2s2, 2p4. Number of valence electrons is equal to how many? 6. So 6 minus and number of lone pairs 1, 2, 3, 4, 5, 6. 6 minus 6, isn't it? Minus half into number of bond pairs. How many bonds is there? 1. So half into 2 electrons. Each bond is made up of 2. That is equal to 6 minus 7. That is equal to minus 1. The charge present on this oxygen is minus 1. Already we learned previously. Similarly, you can find the charge present on this oxygen. You will get plus 1. I am writing directly. That is equal to oxygen. Oxygen is 6. Directly I am writing 6 minus number of lone pairs 1, 2. 6 minus 2 minus half into number of bond pairs 1, 2, 3. 3 bonds 6. That is equal to 6 minus 5. That is equal to plus 1. The charge present on this oxygen is plus 1. Now find the formal charge on this carbon also. Carbon will get 0 because carbon valency, carbon atomic number is 6, it's 1s2, 2s2, 2p2. The number of valence electrons will be taken as 4. So 4 minus, I am writing directly 4 minus formal charge for oxygen 4 minus number of lone pairs 0. So 4 minus 0 minus 1, 2, 3, 4. So 4 2s are 8. So 1 by 2 into 8. That is equal to 4 minus 4, 0. The formal charge on this carbon is 0. Now this is the charge we find out. Then this structure I am labeling as 2. This is the second structure. Now this is the first carbon, this first oxygen, this is the second oxygen. Apart from this, suppose this pi bond, this bond from present between the carbon and second oxygen, if it is moved here, so the bond present between the second carbon and the second oxygen is moved to the between first oxygen and carbon. As a result, you will get one more structure. What is the structure is C triple bond O, single bond O, isn't it? This has again one lone pair, this has again 3 lone pairs. Now the point is, this is the positive charge, formal charge is +1, this is the -1. This structure I am labeling as 3. First structure, second structure, this is a third structure. So one structure is converting into another structure. What is the thing we find out here is, the position of atoms remains the same and arrangement of only electrons is different. So these are the resonance structures of carbon dioxide. And one structure directly won't converting into another structure, we have to write a resonance hybrid here also. The resonance hybrid will be all the structures I am writing. These structures 1, 2, 3 are called as resonance structures. These structures are called as resonance structures. Now I am writing the resonance hybrid for carbon dioxide molecule. So this is the carbon and this is the second oxygen and this is the first oxygen. Right, one bond is moving from carbon to oxygen like this. So this bond I am labeling as like this. So this is a resonance hybrid. The resonance hybrid of carbon dioxide molecule. This is the concept of resonance. The resonance is defined as the existence of 2 or more Lewis structures for a given molecule is called as a resonance. The main difference is, the main point is, the resonance structures have same position of atoms, similar position of atoms or nuclei, but they have a different arrangement of electrons. This is resonance. Next class we will come out with another chemical bonding topic.